Hello, AP Stat students. This is going to be our first look at how we set up a simulation in section 5.1. And so a simulation is where we're basically pretending to do some random or chance process without literally doing that process. A lot of times doing an actual event may be too complicated or too difficult to perform, so we're going to simulate it and pretend to do it. And we're going to see if we can use that simulation result to try to estimate what's the probability of something happening. So the key thing when we imitate some chance behavior is we have to create a model that accurately reflects the situation. And when we do that, that's called a simulation. So there's kind of 4 key steps to any simulation. First off, we got to know what is the thing we're interested in answering. What is the question that we're interested in? And then we have to tell how to do that. Now, here's kind of the 4 main pieces. When it says describe how to use a chance device to imitate the simplest component of the process, a chance device could be your calculator's random number feature. It could be drawing slips of paper out of the hat. It could be a random number table. But when it talks about the component, to me, the component is the simplest, smallest thing that you are going to simulate. And we'll look at an example to help us see that. But we have to identify how we're going to do that. When you, for example, if you're going to pretend to flip a coin, you might have your calculator spit out random numbers of 1s and 2s. And you'd have to say, if it gets a 1, that means head showed up. And if it gets a 2, that means tail showed up. So we have to identify how we're going to represent the outcomes of that process. And then the final pieces are we're going to do lots of trials of it. We've already learned the law of large numbers says the more of a chance process you do, the more often you do it, the graph will level out at that estimate of the true probability there. So we want to do as many trials as we can realistically. And then we're going to keep track of the response variable. The response variable is a term we used in our experimental design chapter, but response variable here indicates what are you interested in. Are you keeping track of how many heads showed up? Are you keeping track of how many 3-point baskets were made? What is it you're interested in? And at the end, we got to make a conclusion. So you did a simulation, you got a bunch of these results. What does it tell you about what you're interested in to begin with? So again, we can use our physical devices like a slips of paper in the hat. We can use our random number table, or we can use technology like our calculator's random number feature. And I think today for this example, we're going to use the calculator's feature to make it easy. So here's the problem. Picture you're in this situation. You're in college next year, and you're in a class, and your professor gives you a 5-question multiple choice quiz. You take a look at this quiz, and you are absolutely just completely blank on it. You realize you know nothing about it. This quiz might as well be about nuclear engineering and be written in Russian. You literally have no clue whatsoever. So you just resort to guessing. You got no other option. You just got to guess. So the question is going to ask us, if you go on and you just randomly guess these questions, and each question has 4 options, A, B, C, or D, and you completely guess, you're hoping that you pass, but in order to pass, it says you got to get at least 3 questions correct. So again, 5 total questions. You pick A, B, C, or D for each one. You need to get 3 right at least in order to pass. The question we're interested in is this: what is the probability you will pass just by randomly guessing each answer? Now, that question is kind of a difficult question to answer just purely by calculating things, by mathematics alone. But we can simulate it and try and get a reasonable estimate of the probability of doing that. So here's how we're going to do it. You're going to need your calculator out, and we're going to talk about those 4 parts. So I've kind of set up the problem over here again. So remember the basics. There's a 5-question multiple choice quiz. You have to pick A, B, C, or D, and you got to get at least 3 correct. But you have no idea what you're doing, so you're completely guessing. So let's think about these 4 pieces, and then we're going to actually do the simulation. So what's the component? Well, the component to me is the simplest thing that you're going to simulate. So yeah, we're trying to take a quiz, but this quiz has 5 questions on it. So I'd be picturing the component, the simplest thing is we have to just answer one question. Before you can answer an entire quiz, you got to answer one question on the quiz. So what we're going to try and decide is, how do you know when we simulate this, when you answer that single question, how do you simulate whether you got that correct or not? Now, there's a lot of ways you can do this, but what I'm going to do is I'm going to use my random integer feature on the calculator. I'm going to come over here and just remind you of it. The random integer feature is over here under the math button, under PRB for probability. We've used this before, but I can tell the calculator to give me random integers between 1 and 10, for example. And if I hit enter, it just starts popping out random numbers between 1 and 10 or whatever. You could set any numbers you want to. So what are we going to do over here for this problem? Well, I'm thinking because there are 4 options when you answer this question, I'm going to do this. I'm going to use random integer on my calculator, and I'm going to have it give me random numbers between 1 and 4. Now what I have to think of is this. So it starts spitting out these numbers. Here's a 1, here's a 3, here's a 2, here's another 1, here's a 4. What do those numbers mean in terms of did I get them correct or incorrect on that question? So I've got to think again on these 4 options up here. 1 out of those 4 is a correct option, and 3 of those 4 is wrong. So what I'm going to do is, since I've created 4 options coming out of here, I'm just going to choose one of them to be representing that I got it correct, and the other 3 mean I got it wrong. So I'm just going to identify this. I'm going to say if I get the number 1, that means I answered that question correct, and I am a happy camper on my way to passing this quiz. If I got 2, 3, or 4, then that means that I answered that question wrong, and I missed it. Okay? So that way I can do, over here on my calculator, I can say let's set up random integers between 1 and 4. And this is answering single questions at a time. So for example, right there's a 1. Oh, well that means I made a good guess. I guessed that first question correctly. So I got 1 correct. I can hit enter and just do it again. Here's a 3. That's a miss. So I missed that question. Here's a 2. That's a miss. So I missed that question. Oh, there's another 1. I got another 1 correct. Okay, the question is, I could keep doing this over and over and over and over again, but how do you know when you stop? That's what a trial is asking you. A trial says, when are you done simulating these individual questions and these individual components? Well, our trial is going to be done after we've answered 5 questions. So the trial is just, I'm going to answer 5 questions. That's when the quiz is over, and the trial represents a single quiz. So I'm going to answer 5 questions. What am I keeping track of? The response variable is what are you going to keep track of? I simply want to know this. What is the number that I got correct? And did I pass? And I know in order to pass, I got to get at least 3 correct in order to pass. So we're going to do a few trials of this. And we're going to keep track of, I'm going to show you how to set this up, and then ultimately we're going to make our conclusion over here and say, what do you think? What really is the probability that you pass if you're completely guessing? So we're going to do it completely on the calculator. Here we go. I'm going to clear it out and I'm going to start. I know I got to answer 5 questions. So here we go. And I'm going to keep track of my outcomes over here. So I'm just going to use, let's say, check marks for I got it correct and X's for wrong. So that first question is wrong. That question is wrong. That's a 3. That's wrong. That's a 2. That's wrong. Oh man, I only got 1 question left. Ooh, I got the last question correct. Great. So I'm going to check mark that and say, good job, I got that last one correct. But that's only 1 correct. So ultimately, did I pass? No, did not pass. Now, here's a quicker way you can do this on the calculator. Instead of doing the questions one at a time, I can set this up and say, calculator, give me random numbers between 1 and 4, but I can give it a third number and say, give me 5 of those numbers between 1 and 4. And some of your calculators, I think, will have a little menu option where you can, it asks you for like lower and upper and how many you want. It might use the letter N to stand for how many you want. But now I can do an entire quiz at once. So here's an entire quiz. And it's got, I got a 4, 1, 4, 4, and 3. Okay, well, I missed the first one. There's a 1, though. That's good. Got it right. And a miss, and a miss, and a miss. So here's another quiz where I only got 1 question correct. Did I pass? No, I did not. All right, we're going to knock out 10 of these total. Here's a quiz where I got the first one right, missed the second, got the third, and missed the fourth and fifth. Ooh, I did better. I got 2, but I still didn't pass. Here comes a fourth quiz. That I got everything correct, or sorry, I missed everything except for the third problem. That's only 1 right. No pass there. Here's one where I biffed everything. So I got 0 correct. No, I did not pass that. Here's one, again, where I have a single question correct. 1 question correct. No, I didn't pass. Now, if we were doing this physically in class, I'd have you guys all be doing this, and we'd start to hear a few people might be saying, yeah, I passed one. I still haven't passed one. Okay, there's another one. Quiz number 7, trial number 7, I should say. Got the third question right. Missed those 2. 1 question right. No, did not pass it. Here's one. I missed everything but the last question. 1 question correct. No, still didn't pass. Hoping I can pass at least 1 quiz. Here's one. Oh, came close. Missed it. Got the second question. Miss. Got the last question. 2 correct. Still not a pass. And here's my 10th trial. I missed the first 3 questions. Got the last one. There, got the fourth one, and I missed the last one. 1 question correct. No. Now, I guarantee if we were doing this in class, there would be some people who would have some trials where they ended up passing this pretend quiz because they would have gotten at least 3 correct. Now, that never happened to me on any of these, but this is all I have to go with here. I might just try it. We'll look real quick. Here's quiz number 11, didn't pass. Quiz number 12, didn't pass. Quiz number 13, didn't pass. 14, didn't pass. 15, no pass. 16, no pass. 17, no pass. 18, 2 questions right. That's not passing. 19, no pass. 20, no pass. Now I'm curious, how many is it going to take? 21, 22 didn't pass. Oh, trial number 23. Okay, now I didn't write all these out, but here comes on the 23rd pretend quiz, the 23rd trial, I finally got 3 correct, and that's a pass. So here's what I'm going to say in my conclusion. According to my simulation, this is kind of that cover your butt language that we've talked about before. According to my simulation, the probability of passing this quiz is 1 out of 23. Okay, I only passed it 1 time out of 23 trials, and I'm going to go ahead and change that into a proportion, into a decimal version. 1 out of 23 is just a little bit more than 4%, 0.043. Okay, so it looks like it's a pretty small chance that I would pass this quiz just by completely guessing. Again, if we wanted to have more accurate results, don't stop at 10 quizzes. Don't stop at 23. If we did this together in class, we'd have hundreds of these trials that we would have done, hundreds of these pretend simulated quizzes, and we'd be getting a little bit closer to what the truth is. We'd see that line start to level out at some number like we did with our coin flipping. Okay? So there's an example simulation using a random number feature on your calculator.